So now we're gonna be doing the chemistry week 9 AMS quiz. It's really easy this week. It's all memorizing. Like, you don't have anything to actually not study, or like to study, I mean. It's all memorizing. Your best shot is studying the topic 11, chapter 11, topic 11, qualitative chemical analysis notes. Memorize it. If you have it memorized, you are guaranteed over 90, because the entire exam is about it, and it's really important, and it's all memorizing. So let's start. Which of the following are used to test presence of ammonia gas? Ammonia gas, which is NH3. So ammonia, we know it's a basic gas. We can know this, that if you read the topic 11 notes, it is gonna tell you that ammonia is basic. And if you want to find ammonia, what's it called? You have to use a moist red litmus paper, because it's basic. It's gonna turn red litmus paper to blue. And a rod dipped in concentrated HCl. Now this one, if I'm being honest, I didn't really find it mentioned anywhere, but it is 1 point, and yeah, I'm trying to look for it here. I cannot see it. No wait, that's nitrate. Yeah, so I don't think it's there in the paper, but just memorize it. It's basic, so it turns red litmus paper blue. So that's it for ammonia. It doesn't have a glowing splint, it doesn't have a lighted splint, and it doesn't turn blue litmus paper. Okay. So we know that you use NH3 and NaOH. Both of them, you use them to test for cations in a solution. So every time you have one of these experiments, you're gonna see that there's two different cases, one with ammonia and one with NaOH, sodium hydroxide. So when you mix NH3 with a solution that contains calcium, there is gonna be no precipitate. But when you mix it with NaOH, NaOH, it's gonna give you a white, insoluble precipitate. PPT. Precipitate. With NaOH. But with NH3, no precipitate forms whatsoever. So let's move on to the next one. Okay. So here we have to read the questions really well. You added NaOH to unknown solution Y. Pungent smell gas. Okay. Now when we see pungent, that alone can give us the answer, because we only have two pungent or strong smelling gases. The only two that have a pungent smell are chlorine gas and NH3. Oh wait, these are gases. Here we're using ions, sorry. Okay, so for ions it's easier. I think NH4 plus is the only cation that has a pungent smell. And let me check. Yeah, so NH4 is the only cation that has a pungent smell. So when you see pungent smell, it's always something to do with ammonia or ammonium. And red litmus paper blue, because like we said in the previous example, these are basic, so they will not react with NH3, of course, because the NH4 is NH3 but like in a different way. And they're basic, so you can only use them with moist red litmus paper, and they'll turn it blue. So red to blue. Let's move on. Okay, so here it's asking you, what is a substance that dissolves in water to give off solution containing ions? This is a definition and just memorize it. Electrolyte, when it dissolves, so with water, electrolyte plus water equals ions. Just memorize it. Let's move on to the next one. Okay, so this question is asking us about water at 25 degrees Celsius. Kw, this value here is a constant. Kw, no matter where you go on planet Earth, it's always gonna be 10 to the power of negative 14. Always. And that OH and H plus, they are gonna add up, both of them, to make this. So each one, sorry guys. Okay, so each one has to be 1 times 10 power negative 7. Always. Or sometimes you might just see it as 10 power negative 7, the option. Pick it. It doesn't have to show the 1. 1 is just there for scientific notation, I guess. So OH and H plus, always, both of them are 10 power negative 7 in normal water, in pure water. In pure water at this temperature specifically. So let's move on to the next question. Okay. So here they're telling us this is the dissociation of water, and that H plus times OH minus is 1 times the power of negative 14, and this is Kw, our constant. When we increase the temperature of the system, it will absorb energy. It's gonna absorb energy because this is endothermic. See? It's endothermic reaction, so of course it's gonna absorb. And the value of Kw increases. Because remember guys, Kw is 10 power negative 14 only at 25 degrees Celsius. Only. At any other thing, it's not this value. It's gonna increase when you increase temperature, decrease when you decrease temperature. So let's move on to the next one. Okay. Aqueous solutions means solutions that are containing ions. And the ions are always going to be OH minus and H plus. No, this isn't for this week's AMS, but know it for next week's AMS. OH minus, a high concentration of it makes it basic. And the high concentration of H plus ions is going to make it acidic. So just know these as information for our next AMS, but they're not in with us this week fully, I think. Let's move on. Okay, this question, again, all memorizing, but I'm gonna give you the keywords that when you see them. Yellow-green gas, there is only one yellow-green gas, and it has a choking smell. And bleaches most litmus paper. It doesn't make its color into anything. It bleaches it, completely like takes away its colors. Only one gas this could be, it's chlorine. It's the only gas this could be. Yeah, so when you see the word bleaches and when you see the word choking, or sometimes they could write it as pungent smell, but most likely it's choking more than it is pungent. And yellow green, or you might see it sometimes written as pale green, both are the same. This is always going to be chlorine. A colorless, odorless gas that will light a glowing splint. When you see lit or light a glowing splint, it's oxygen. But when you see pop sound, lit splint, it's hydrogen. So what this means is that when you have a glowing splint and you put it on fire and you blow the fire out, if you put it near oxygen, the fire is gonna come back. Now here, a colorless, odorless gas that makes a pop sound, when you put a lit splint, when you put a splint that's on fire near hydrogen, you're gonna hear a pop sound like that, like it's just a pop sound. And this is always gonna be hydrogen when you see the word pop. A colorless gas with pungent smell. Okay, so what we know is we have two gases that have a pungent / choking smell. One is colored, the other is colorless. When you see colorless, it's ammonia. When you see colored, it's chlorine. Easy. A colorless gas that turns lime water milky. If you took bio last year, you shouldn't have any problem with knowing this. carbon dioxide. It's pretty clear. CO2 will always turn lime water milky. And a colorless gas that decolorizes a purple acidified aqueous potassium manganate. Anytime you see the word potassium manganate, know it has something to do with sulfur. In our papers, we don't have anything that's with potassium manganate unless it's sulfur. So yeah, that's it for this question. Let's move on to the next. Okay, here we have to memorize a small formula. When they are asking you for concentration of hydrogen or OH minus molecules at a certain concentration, this is what you do. You're gonna do Kw over the concentration, 0.060. And that is it. You just take your constant, this over 0.060, so 10 power negative 14. Divided by 0.060 is gonna give you 1.66666. It's gonna continue, but they wanted to two significant figures, so we're gonna round this up and it becomes 1.7 times 10 power negative 13. That is it. It's really easy. Just this. This is all you need to do. So even when they give you OH, don't let it scare you. It's the same exact thing. Kw over concentration of H plus or Kw over concentration of OH minus. No matter whatever one they ask you, this is the equation. Let's move on to the next question. Okay, flame test. We need to memorize the colors for the flame test. If you don't, well, you won't be able to get it. Personally, I would just tell you that these are the colors and memorize them, but I'm going to write down all the colors. Lithium, or Li+, is going to be red or crimson. Then you have potassium, K+, is always going to be lilac. You're going to have sodium, Na+, is going to be yellow, always. Then you're going to have calcium, Ca+, is going to be, Ca2+ for calcium. Ca2+ for calcium is always going to be brick red. Now, when you see copper, 2+, always blue, green, bluish green. And finally, barium, when you see it, always gonna be a pale or yellowish green. Yellow, green. Always. So these are your colors. Memorize them. I would make the screen bigger, but I can't. So barium, pale or yellowish green color. So let's move on. So lithium we said was crimson, sodium we said was yellow, potassium we said is violet. Okay. So like I told you in the first question, calcium in NaOH makes a white insoluble precipitate, and in ammonia NH3 NH3 no precipitate, or no reaction either. Actually no, just memorize it, no precipitate. No, not no. It says no reaction, but just no precipitate. So NaOH, white precipitate forms. Now, in this question, you have to look out for the keywords. White precipitate. When you see the word white precipitate, it can only mean a few things. In cations. In cations, it could either be Al, or it could be zinc, or it could be calcium. But we need to continue reading the question to know which one is it. in excess NaOH, it's soluble. So we know calcium, not soluble. So we're gonna remove calcium from our options. Now, in your options here, when you had the drop-up menu, zinc wasn't one of the options. So since zinc wasn't one of your options, remove it and Al. But let's say zinc was one of your options, and it told you it's soluble in excess NaOH and NH3, it's gonna be zinc. But aluminium is not soluble. Not soluble in NH3. Zn is. So that's the only difference in how you're gonna identify which ones it is. Let's move on. Okay. So for this question, it's always gonna be, it's really easy. Equations might scare you, they're not scary. But you need to really be careful. Here they gave you in the original question Al 3+, and they gave you OH minus, and their states, of course, and they asked you what is it gonna turn into. When you see Al and OH, just put them together. Al into OH. And always remember to give OH a bracket, because and now, okay, so another thing before I continue what I was saying, you see the little degree here, or like whatever, the thing up, you put it down, you put it as the subscript of OH. So if this was 3+, OH 3. Since OH is only -1, you don't put a 1 here. So, and we put the brackets here, so because if you don't put the brackets, it's gonna be O1 H3, and it's OH3. OH is a bundle, so you have to put around them brackets. And of course, all precipitates are solid. Now, what my mistake was personally when I was solving the quiz, you'd forget to balance. If you had OH3 here, you can't have OH in the reactant side. Don't forget to balance. If you had OH3 here, this has to be 3OH. And for the name, look, for the names, be careful. You're gonna put the name of your first ion, aluminium, and you're gonna put this. If it is 3 here, you're gonna put brackets I. Let's say it was 2, you put brackets I, and so on. Hydroxide, you put nothing. Hydroxide is always gonna be hydroxide. But there's like 2 more of this question, so you're gonna see what I mean. Okay. You added NaOH to a solution containing Fe2+. Fe2+ with NaOH is always gonna give you slimy green. So with NaOH and NH3, it's gonna give you slimy green color. The only difference, and actually no, there is no difference. It's insoluble in both. Always when you see iron or Fe, always, no matter what the superscript was, no matter was it 2 or was it 3, iron, whatever, is always insoluble in excess. Just know another thing, no matter when you see iron, no matter what its starting color was, it's gonna always change to brown when exposed to air. This is all memorizing. Now, let's move on. Here, okay, I skipped a question. Yeah. Fe2+ gives you slimy green, Fe3+ gives you rusty brown. Or you might see it as reddish brown. Red brown, both work. You're gonna see both are the same thing. Okay. Again, like we said, this question, you're gonna see a lot of it. Or like it's 3 times in this quiz. So what you have to complete is, like we said, don't get scared, just look at Fe and OH. You're gonna put Fe, OH. Now we have to balance and put superscripts. You move this superscript down, Fe3+, or like FeOH3, solid, and we put a 3 from here, so we have to balance it with a 3 from here, of course. Now this is Fe3+, so you put iron, bracket I, because it has to be in Roman numerals, hydroxide, whatever. If you don't put it like this, you're not gonna get the mark for it at all. You're gonna not get the mark, never. So don't forget the number of the things. If it's 1, you don't have to put a number. Okay? But for things like iron, always put the number because there's many types of iron. Now for the aluminium question, I prefer if you put it, but they won't remove marks if you don't, because aluminium is aluminium. There's only one type of aluminium as I know. But iron, you have to specify always. And also for copper and chromium, also you always have to specify. But we're gonna not look at those now. There's another question later. Sorry. Okay. There's one word here. Pale blue. Blue, whenever you see the color blue. If it was a flame, if it was whatever, blue is always copper. Copper is always blue. Its flame is blue. Its precipitates are blue. And it's insoluble in NaOH. When you see insoluble and NaOH and pale blue, copper. Immediately. Let's move on. Again, like I said. So, for this question, a few drops of NaOH were added to this. Pale blue, okay, we don't really care about the question. They just want us to balance. So, you see the copper, you see the OH, put them together. Copper, OH. You see the number here, you put it down here, and you give it the solid. And then when you have a 2 down here, we have to put it here. That's it. Only. And like I said, copper is one of the things you always have to give the number to. And it isn't always copper II. Sometimes they could tell you copper 3. Then you have to put III. You always have to be aware. So it's copper II hydroxide. Moving on. Okay. Upon adding NH3 to a solution of copper. Okay, so copper to plus in NaOH and in NH3. Let's see. NaOH, NH3. Oh wait, it's NH3. In NaOH and in NH3 always equals blue. In NaOH, it's insoluble in excess. In NH3, it's soluble in excess. So let's see. NH3, copper, pale blue. So this is light blue. It has to be pale at the start. That dissolves in NH3. See, it's soluble in NH3. And when it dissolves and it becomes a not precipitate, so it's gonna form deep blue. So later on, when you add excess, it's gonna be dark blue, like the color of my writing right now. Let's go on. Halide ions in solutions. So these are 3 and it's always gonna be 3. In PB or in AG, they're the same colors. Wait, this is PD. PB. In AG and PB, chloride is always gonna be white. Bromide is always gonna be cream. Iodide is always gonna be yellow. So just know it. White, creamy, yellow. Whenever you see AG, PB, chloride, bromide, iodide, white, creamy, yellow. Always. Now let's move on. Okay, let's identify the sulfate ions in the solution. Anyways, when you add an acidified solution of barium nitrate to SO4, we know barium nitrate, it does not dissolve in SO4. SO4 is soluble in most things other than barium nitrate. I even have it in my notes right here. Wait, let me just see. Sulfates are soluble except in iron, in silver. This is silver, I mean lead, barium, and calcium. So let's go back to the quiz. And yeah, so this isn't soluble in this, so always a precipitate is gonna form. And SO4 forms a white precipitate. You could see this also on the notes or on like the papers. Okay, so here we have a question that tells us you added a few drops of NaOH to zinc. I told you zinc is gonna be white and always soluble. Zinc always soluble. NaOH PB, it's gonna form also white, but except PB is soluble in NaOH, insoluble in NH3. Memorize. These I can't really help you explain them. All memorization. Okay, these two questions. When you see electrolyte and you see dissolves and exclusively gives ions, it's strong. Always. But the next one, when you see dissolves and de-associated to limited extent means it's weak. And that is it for this quiz. It's really easy, all memorizing. If you memorize it well, I can guarantee you're gonna get good. But memorize them well. So that's it. Hope you have a nice day. Bye.